So finally, in this chapter, we are going to look at aromatic compounds. This is the final unit. And once we are done with the unit, we will go into the exercises and solve some problems and review the chapter. So the final unit is aromatic compounds. Aromatic compounds are cyclic compounds. So we have discussed cyclo compounds before. But this is cyclic compounds with a difference. So we'll go in and see, yes, benzene. This is an aromatic compound. And how this is different from a cycloalkane is there are alternating double bonds in this cyclic compounds. And these cyclic compounds have 6 carbon atoms in a ring. So aromatic compounds have 6 carbons in a ring with a rotating, alternating double bond. So this double bond rotates in this molecule. So this double bond can be located here, here, and here. So this is a rotating, alternating double bond molecule with 6 carbon atoms. So aromatic compounds are based off of this molecule, which is benzene. So in this, we are going to name aromatic compounds, draw skeletal formulas. That'll be the learning goal for us. And the molecular formula for benzene is C6H6. So you can see there are 6 carbon, like I said, and there are 6 hydrogens. So that is the molecular formula. That is your balance stick model for benzene. And this is the basic unit of aromatic compounds, is benzene. Ring of 6 atoms, each bonded to 1 hydrogen, 3 alternating double bonds. So this is your structural formula. You can see the expanded formula. This is the skeletal formula. So you see the double bond, and the double bond is alternating. So this is your expanded. You can also set up the double bond in this way, a circle. It keeps alternating. Or this is your skeletal formula. So you can see how this is different from cyclohexane. Cyclohexane is a saturated hydrocarbon. You do not see a double bond in cyclohexane. So this is benzene. So naming aromatic compounds. And a single substituent as benzene derivative. So benzene, adding a substituent. So this substituent is a methyl group. So our IUPAC name will be methyl benzene. This substituent is a amino group, amino benzene. This substituent is a hydroxyl group, hydroxy benzene. And these are the common names. So IUPAC name. So these are IUPAC. These names are allowed, so we can call this toluene, aniline, phenol, but the chemical name, proper name. So if you have just one substituent in the benzene ring, we do not have to name or number the substituent. Once you have more than one, we are going to number, and we'll see in the further examples. When there are 2 or more substituents, the benzene ring is numbered to give the lowest number to the substituents. So this is a benzene with 1 substituent. So we do not have to number. Chlorobenzene. There are 2 substituents. 1, 2 are the lowest possible numbers we can assign. So 1, 2 dichlorobenzene. 1, 3 dichlorobenzene. 1, 4 dichlorobenzene. So we are going to number when we have more than one, giving the lowest numbers to the substituents. When a common name such as toluene, phenol, aniline can be used, the carbon atom attached to the methyl hydroxyl amino is numbered as carbon 1. So when you have an amino group, hydroxyl group, or a methyl group, you give that number 1 and start 1, 2, 3. So 3-bromoaniline, we are using the common name. 4-bromo-2-chlorophenol, OH, we are using the common name. So 4-bromo, B, alphabetic, comes before C. So we go with the bromo first, alphabetically, okay? So this is toluene. So that takes the number 1, 2, 4, 6. Either way, you will go 2, 4, 6. So 2, 6, dibromo, B comes before C, 4-chlorotoluene. So when you have a amino, hydroxyl, or methyl, we're going to use the numbering starts with that substituent. So the other substituents are named alphabetically. Now chemistry, some common aromatic compounds. So toluene is used as a reactant to make drugs, dyes, explosives. So this is a compound used in drugs and dyes and explosives. This is trinitrotoluene. So this is the toluene molecule. Methyl and benzene is toluene. So number 1 here, 2, 4, 6, tri, this is the nitro group, toluene. The benzene is also found in amino acids. Amino acids are the building blocks of proteins. So again, benzene, and there is your amino acid, a very simple amino acid. Amino acids contain the benzene ring. So benzene is also found in ring in pain relievers, ibuprofen. It's also found in flavoring agents. This is acetaminophen, aspirin. All these contain the benzene ring. This is a flavoring agent. It also contains the benzene ring. Now, let us select the correct name for this. Now, I am looking at a benzene ring and 1 substituent, chlorine. So when there is just 1 substituent, I do not have to number. So I'm going to go with chlorobenzene on this. I'm looking at this, it's a compound, so I see a methyl substituent. So I can go, I have to give number 1 to the methyl substituent. So this is toluene, benzene, 1, 2, 3, 1, 2, 3. So I'm going to say 1,3-dimethylbenzene. So if I say 1 here, it becomes 3. If I say 1 here, this is 3. 1,3-dimethylbenzene. Let us see if we are correct. This is chlorobenzene. This is 1,3-dimethylbenzene. So we were right. And this is a flow chart. This is also in your book that gives you a review or puts all that information together that we have discussed in this chapter. And what I'm going to do now is get into the textbook, and we'll go into some exercises and work on some problems.